Okay, today we're going to look at section 2.6, graphs of basic functions. We're going to start with some very simple functions. I'm going to start with the identity function, which is the line y equals x, right here. Then we have the absolute value function, y equals the absolute value of x. Note the v shape. Then we have the square function, y equals x squared, which we'll see a lot more later on. Then we have a cubic function, y equals x cubed. Note the curved shape. Then we have a square root function, y equals the square root of x. Note that y is only a positive. We're graphing on a Cartesian or rectangular coordinate plane, so no imaginary numbers, no complex numbers, so y will always be positive in that case. And then we have a cube root function, which is similar to the cube function, but it's turned the other way. Same basic shape. Okay, then we have a reciprocal function, y equals 1 over x. And we have the reciprocal squared function, y equals 1 over x squared here. These are things we may or may not see throughout the term. So that brings us to continuity. Again, this is something that we look at here, but mainly if you're going to be going on to calculus, you will definitely see this again. Function is continuous over an interval of its domain if its hand-drawn graph over the interval can be sketched without lifting the pencil from the paper. Additionally, if there are any holes, jumps, or vertical asymptotes in the graph, then it is discontinuous at those values. So determine the interval of the domain over which this function is continuous. In other words, what values of x which is continuous? Well, I can draw over it without lifting my marker the whole way. Now there's no arrow on the end, so it does stop at 5. And note it starts at 2. So the domain in which it's continuous is -2 to 5. Here to here. Okay, so let's look at this one here. I can go this way. Keep going, keep going, keep going. Here, and it stops. I have to pick up my pencil. So I started at -6, and I go to -1, and it's continuous. And I guess in reality, might want to point out that for the closed circle. So we may want to go ahead and use the brackets because it includes those points. Okay, then it picks up here at -1, but it's not included. And it goes on and on and on to, looks like 5/2. So that is where it's continuous. Same thing here. I'm starting to think there's supposed to be arrows on this, but we'll keep going. And draw it all. It starts at 5 and goes to 1, but it doesn't reach 1. And here it starts at 1 and it goes, that's -5. Starts at 1 and goes to -5. Again, I'm wondering if this is saying this continues to infinity. But you get the general idea there. Okay, so now we're looking at what's called piecewise defined functions. These are functions that are defined by different rules over different parts of the domain. This one here is piecewise. So we're going to say let f of x be x minus 7 for x less than 3 and 5x minus 10 if x is greater than or equal to 3. So what this means is when x is less than 3, we use this, and when x is greater than or equal to 3, we use this. So f of 6, well, 6 is greater than or equal to 3. So I use this one here, and I have 5 times 6 minus 10, which is 30 minus 10, which is 20. Okay, f of negative 2, well, negative 2 is less than 3. So I have x minus negative 2 minus 7, which is negative 9. F of 0, well, again, 0 is less than 3. So I have 0 minus 7, which is negative 7. F of 3, now f is equal to, x is equal to 3. So we'll use this one again. 5 times 3 minus 10. 15 minus 10 is 5. Okay. Same principle here. We have x squared plus 9 for x less than negative 2. And the negative of x squared minus 4 if x is between negative 2 and 10, including negative 2. So negative 1 is greater than negative 2. So here, so I have the negative of negative 1 squared minus 4, which is a negative of 1 minus 4, which would be negative 5. Okay. Okay, I have negative 2. I'm using the same equation. It has equal. I have the negative of negative 2 squared minus 4, which equals the negative of 4 minus 4, which equals negative 8. Okay, now I'm looking at f of 4. Well, 4 is greater than negative 2 and less than 10. So it's the same thing. The negative of 4 squared minus 4 equals a negative of 16 minus 4 equals negative 20. Okay, now we have negative 4. In that case, we're using this one because negative 4 is less than negative 2. So I have negative 4 squared. Note it says x squared, where this says the negative of x squared, plus 9. So I have 16 plus 9, which is 25. And 12, well, 12 is greater than 10, so it would be undefined. Okay, so now let's see how to graph this. Okay, f of x equals x squared for x less than 0, and x plus 2 for x greater than 0. So at 0, it has no value at all. So we'll look at x squared. Now, the magic point is 0. So we'll figure that out. If x is 0, y is 0. But it's not equal. So that point is not part of the graph. So we put an open circle. Now we're looking for x is less than 0. So we go to negative 1. Negative 1 squared is 1. So here's my point here. Then maybe to get a good idea what this looks like, let's go to negative 2, also less than 0. And that's 4. And as experience has showed me, what I'm looking at is something like this. Okay, Now my next one is x plus 2. And again, x is greater than 0. So I'll figure out 0. That gives me 2. So when x is 0, y is 2, but it's not included. So it's an open circle. So now we need to know greater than 0. So I do 1 and I get 3. And I go 2 and I get 4. So that's that part. That's our piecewise equation, our piecewise function. Okay, let's look at one more here. Again, f of x equals 5 plus x if x is less than -4. Negative x is f is between -4 and -5, and or -4 and 5 are inclusive, and x is if x is greater than 5. So we have 3 here. Let's look at that first one. 5 plus x, and that's for x less than -4. So we'll look at -4, which gives me 1. Then I'm going to go less. -5 gives me 0, and -6, which gives me -1. So it's strictly less than. So this point here is not part of the graph. So I look at -4, 1, and I put an open circle there. Then I go -5, 0, and -6, -1, and I have that first part of the line. So we're good there. Now I'm looking for -x, and this is for x equals -4, so we'll use -4, which gives us a +4. So that point there, 4, 4. And let's just use 0, which will give me 5. And then let's use, no, wait. If x is 0, -x is 0. And then let's use 5, and that gives me -5. So I have 0, 0, and I have 5, -5. And I have my line. Again, it stops because that's where that area stops. That's where that piece of the function stops. Then our last function is simply x for x greater than 5. So if we use 5, we're going to get 5, but that one is not included. So we put an open dot there. 6 would be 6, and 7 would be 7, because we have to stay greater than 5. So that's what we're looking at. So there is our piecewise equation in 3 pieces. That finishes up this section. Again, any questions, do feel free to email me. I do check it on a regular basis. And would be happy to get with you or explain things through email, set up a Zoom meeting, anything you think would help you with this stuff. Have a good night.